Okay, so numbers 12 to 15 on your sheet. Number 12, a person pulls a 50-kilogram object along a level surface with a rope. So they're pulling. And if you remember, we said whenever it says pulling with an angle of 30 degrees, it means upward. Okay, so here's my F. This angle in here is 30 degrees. This is going to be Fx. This is going to be Fy. So it says it's a 50-kilogram object. And it says he's pulling with a force of 200 newtons. This will be Fg. This is Fn. This is friction. And it says the coefficient of friction is 0.2. And it wants to know what's the acceleration. So again, first step, do the sum of the forces find the x and y components. So the x component is the opposite side, so cosine of theta should equal fx over f. I would probably do fx equals f cos theta and just leave it at that. But if you didn't, then fx is equal to 200 newtons cos of 30, and you get an fx of 173.21 newtons. Fy will be sine theta. It's equal to Fy over F. Fy is equal to F sine theta. Again, I'd be tempted to stop here, but if you didn't, Fy is equal to 200 newtons sine of 30, and that's a nice pretty number, 100 newtons. And in these ones, you can find these because you're just looking for A, so you can get your value for Fn. So sum of the forces in the y is equal to MAY. It's not moving in the y. Going up is Fn. Going down is Fg, so it's a negative. And Fy is going up, so it's a positive. Solving for Fn, so take your Fg and your Fy over. So it becomes mg minus f sine theta. You could either stop here, or you could get a value for it. So 50 kilograms times 9.81 meters per second squared. And the sine theta you had up there was 100 newtons, so minus 100 newtons. Sorry, I have the paper tilted. 490.5 minus 100. So Fn should be 390.5 newtons. Once you found that, if you want it, you could find friction then. So FFR is equal to mu Fn. And when I said if you want it, what I mean is you could just keep carrying the letters, but since you have the numbers here this time, so 0.2 times 390.5 newtons, 78.1, I think that is. 78.1 newtons for friction. And then go to the x direction. So sum of the forces in the x direction should equal max. And so in the x direction, there's fx minus friction is equal to max. And you're solving for a, so divide by m. So fx was the 173.21 newtons. Friction was the 78.1 newtons we just found, and m was 50 kilograms. What's that on the top? 95, 90, yeah, and then divide it by 50. Ax is going to be 1.902 meters per second squared. Number, 12 is done. Number 13 is also at an angle. And it says a person pushes a box across a level floor. So this time it's downward. So it's an 80 kilogram box and you're pushing. Person's arm makes an angle of 25 degrees. So this is 25. This is Fx. This is Fy. A force of 400 newtons. So F equals 400 newtons. This will be Fg. Fn friction. And it tells us in the question that the coefficient of friction is 0.25, and this time it wants us to find A in the x direction, of course. So again, you could go cosine theta is equal to fx over f. So fx equals f cos theta. Again, I probably wouldn't fill my numbers in. Last time the angle was 30, so it's not too bad. 25, sine and cos of 25 is nasty. But if you did this, so it'll be fx is equal to 400 newtons cos of 25, and you get an fx of 362.523 newtons. And then in the y direction, it will be sine theta, fy over f. So fy is equal to f sine theta. Fill in your values, 400 newtons, sine of 25. And when you do, you get an fy of 169.047 newtons. But you could have just stayed here at the fy equals f sine theta until later if you wanted. Sum of the forces in the y equals may. This goes to 0. So remember, when you don't know where to start, there's something at an angle, break it into components, and then start with sum of the forces in the y. Fn is going up, it's positive. Fg is going down, it's negative. And Fy is going down, it's negative. In the y, you are always trying to solve for Fn, so take the other two over. Fg is really mg, and it becomes positive. And Fy is really f sine theta, it becomes positive. If you want to find the value, 80 kilograms times 9.81 meters per second squared, and Fy we had as 169.047 newtons. And it gives you an Fn of 953.847 newtons. Okay, this time you can't find friction because you don't know mu. So you can't do FFR equals mu Fn, but you can do sum of the forces in the x direction. In the x direction, we have Fx minus friction equals max. And we don't know friction. So you can bring it over to that side. So this will be f cos theta. I have a tickle. Excuse me. Minus max equals friction. Sorry. F cos theta is 362.523 newtons minus 80 kilograms. Oh shoot, I thought it was A we didn't have, or mu we didn't have. Alright, friction is equal to mu Fn. Was it the other one we were looking for mu? 0.25 times 953.847. Sorry, I looked at the wrong question when I was looking at what I was solving for there in the middle. So you get 238.462 newtons for friction. And so up here, don't take the friction over. You're solving for A, so divide both sides by m. So F cos theta minus friction over m. Sorry about that. Can I blame it on the tickle? Probably not, because I made the mistake before the tickle. 523 newtons minus 238.462 newtons divided by 80 kilograms. And you should get an AX of... I was just double checking to make sure I really was supposed to be solving for A. You should get an AX of 1.551 meters per second squared. Sorry about that mess up in the middle there. I was just solving for the wrong thing. I should have looked at my givens where it said A question mark. All right, the next two are going to be the ones where you have to solve for mass and force. So I'll do those in a separate video, and I'll get a drink of water before then.